Hello, in this question, you were asked to find out current I sub 1, I sub 2, I sub 3 and equivalent resistance for the given circuit. Here, the combination of resistance in the circuit cannot be expressed in terms of combination of series and parallel resistance. So we have to use Kirchhoff's voltage rule and Kirchhoff's current rule to solve this problem. Let's mark the points in the circuit here. Let's say this is point A, point B, point C, point D, point E, point F. The current along the branch BC is I sub 1, along the branch BD is I sub 2. At point C, the current going towards the point C is I sub 1, while current going away from point C is I sub 3 and current along the branch CE. So since current going towards the point C and away from point C must be equal, the current along the branch CE must be equal to I sub 1 minus I sub 3. Similarly, if you look at the point D, current going towards the point D is I sub 2 and I sub 3. Therefore, current going away from the point D must be I sub 2 and I sub 3. Now we have to use Kirchhoff's voltage rule to find out the current in these different branch. For Kirchhoff's voltage rule, we have to take we can take three different loops here. The first loop is, let's start from point A. We'll go from point A to B, B to C, C to E, E to F, and again point A. We'll go along this path, and Kirchhoff's voltage rule says the sum of voltage along a closed loop must be 0. The next loop we will use here is from point B to C, C to D, D to B, and from B to C again. Along this path, if we look at the voltage, sum of all the voltage must be 0. The another loop we will use here is C to E, E to D, and D to C again. If we move along this closed path, the sum of all the voltage must be 0. So let's write the first one. Along loop A, B, C, E, F, A. From A to B, there is no component to drop the voltage. From B to C, we are moving along the direction of current, so there is voltage drop, which we marked as negative. The voltage drop is product of current and resistance. Resistance 1 ohm, current is I sub 1, so negative I sub 1 is the voltage drop along the branch BC. Along the branch CE, we are again moving along the direction of current. So voltage drop is negative. Resistance 3 times total current on this branch is I sub 1 minus I sub 3. From point C to F, there is no voltage drop. From point F to A, we are moving along the direction of current from negative terminal of the battery to the positive terminal of the battery. When we move from negative terminal of the battery to the positive terminal of the battery, the voltage change is taken as positive 20 volt. So there is no more component to drop the voltage. Sum of all this must be 0. Let's rearrange this equation. I sub 1, we have negative I sub 1 here, negative 3 I sub 1 here. So negative 4 I sub 1. We don't have I sub 2, 0 I sub 2, and we have negative 3 times negative I sub 3, which is positive 3I sub 3. Let's subtract 20 volt from both sides of the equal sign. So this would be negative 20 volts. We are writing this in standard form. Let's mark this as equation 1. The second loop we are going to use here is loop BCDB along loop B, C, D and B again. So when we move from B to C, current is I sub 1, voltage is 1 ohm, so negative I sub 1. We are moving along the direction of current, and from branch C, point C to D along branch CD, we are moving along the direction of current, resistance 5 ohm. So voltage drop is negative 5 times I sub 3. From point D to B, you noticed that we are moving opposite of the current. So voltage drop is positive, resistance 2 ohm, and current I sub 2. Let's do not write ohm here. We'll take care of the unit later. So positive 2 I sub 2, which is equals to 0. Let's rearrange this equation in standard form. Negative I sub 1 positive 2 times I sub 2 minus negative 5 I sub 3 equals to 0. This is equation 2. Now let's take third loop, which is CEDC along loop CDEC. When we are moving from C to E, we are moving along the direction of current. So voltage drop is negative, resistance 3, and current along this branch is I sub 1 minus I sub 3. I sub 1 minus I sub 3. When we move from point E to D, we are moving opposite of the current. So voltage drop is positive, resistance 4 ohm, and current is I sub 2 plus I sub 3. And when we are moving from point D to C, we are again going opposite of the current. So voltage drop is positive and resistance 5 ohm, current I sub 3, which is equals to 0. Let's write this equation in standard form with the coefficient I sub 1, I sub 2 and I sub 3. We have negative 3 I sub 1 here and no I sub 2 and I sub 3. So negative 3 I sub 1. Look at the I sub 2 here. We have I sub 2 here, only positive. Nowhere else we have I sub 2. So positive 4 I sub 2, positive 12 I sub 3, which is equals to 0. This is equation 3. Now we have 1, 2, 3 equation, and I sub 1, I sub 2 and I sub 3. 3 unknown. If we rearrange this equation and if we substitute one in another, we can solve this problem easily. Let me rewrite them together. To remove I sub 2 from these two equations, let's multiply equation 2 by 2 and subtract with equation 3rd. This will change the sign, this will change the sign, this will change the sign. So we multiply equation 2 by 2. This will be 2, this will be 2 times 2, this will be 2 times 5. So negative 2 I sub 1, positive 3 I sub 1. So we have I sub 1 here. We have 2 times 2, 4 I sub 2. We have negative 4 I sub 2. I sub 2 is removed. We have 5 to the 10, negative 10 I sub 3, negative 12 I sub 3, so total negative 22 I sub 3 equals to 0. Let's mark this one as equation 4th. Now we have, let's rewrite equation 1 here. We have negative 4 I sub 1 and positive 3 I sub 3 equals to negative 20. This is our equation 1. Now using equation 1 and 4th, we can figure out I sub 3. So let's multiply equation 4th by 4 and add with equation 5. We are adding here, so if we multiply this 4, this becomes 4, this 4 times 22, so 4 I sub 1 positive, 4 I sub 1 negative, this becomes 0. Here we have 22 times 4 I sub 3, which is negative 88 I sub 3 plus positive 3 I sub 3, which is equals to negative 20. This gives I sub 3 equals to negative 20 divided by negative 85 equals to 4 divided by 17. This is amps. This is I sub 3. We got I sub 3. We can substitute I sub 3 in equation 4. Equation 4 is I sub 1 minus 22 I sub 3 equals to 0. That means I sub 1 equals to 22 times I sub 3, which is equals to 22 times 4 divided by 17. So I sub 1 is 88 divided by 17 amps. Now I sub 2, and you can substitute in any of the previous equation. This will give you I sub 2 equals to, I'm not showing the calculation here, this will give you 54 divided by 17 amps. Now total current in the circuit is given by I equals to I sub 1 plus I sub 2, which is equals to 88 divided 17 plus 54 divided 17, which is equals to 8.35 amps. Now equivalent resistance R equivalent is given by V divided by I, which is 20 volts divided by 8.35 amps, which is equals to 2.4 ohms. In this way, we have figured out equivalent resistance in the circuit, we have figured out total current in the circuit, we have figured out current I1, we have figured out current I2, and we have figured out current I3. Thank you.